Most tutorials say occlusion culling is an easy win. 10 minutes and you'll double your FPS. But what if I told you that it could quietly hurt your game's performance? And how to do it better? My name is Anand and I make game dev videos here. Welcome to 100 Tips in Unity. This is episode 11. So remember this. Every optimization trick has a price. Nothing comes for free without any consequences. Occlusion culling is no exception. First of all, for those who don't know what occlusion culling is, it is an optimization technique in Unity and most game engines used to avoid rendering objects that the player can't see because they're blocked or occluded by other objects. You see, by default in every 3D scene, everything gets rendered, even things that the player can't see. This is unnecessary. Occlusion culling makes sure that things that are within the view but hidden behind something else are not rendered at all. A thing to note is that this works only on objects that do not move. It doesn't work on characters, animated objects, etc. For example, imagine you're facing a wall and there's furniture behind the wall in another room. Since the wall blocks your view, none of the hidden room's furniture should be rendered. This is what occlusion culling does. So first of all, why is this a problem? Most tutorials promise a huge increase in FPS. Which is good, right? Not exactly. You see, FPS means frames per second. It is actually not something that is fixed. It is something that is averaged. Which means when the game runs 59 frames in half a second and a single frame alone takes the same half a second, it's still 60 FPS in total. Now let me explain what's actually happening. Let's say your FPS is decided by two things, CPU usage and GPU usage. Actually, there are more things like threads, waiting, sleep, etc. But we have no need to get into that today. Occlusion culling stops rendering occluded objects, meaning we are saving a bunch of performance on the GPU side of things. But in order to calculate what objects needs to be blocked at what time, it takes a bit of CPU usage. While you may save GPU time by not rendering hidden objects, the CPU now works harder deciding what's actually hidden, leading to higher CPU usage. This can be problematic for mobile games or scenes where your CPU is already busy. Also, you should not rely on the stats window. They only give surface level numbers. They don't give you info on what's using CPU, GPU, and how different systems like rendering or physics contribute to frame time. There are also some downsides to occlusion culling. We'll discuss that and when not to use occlusion culling towards the end of the video. Before we get into that, let's learn how to perform occlusion culling in Unity. The very first step in occlusion culling is to actually not do occlusion culling and check if we actually need it in the first place. In short, profile your scene. Press Ctrl 7 to bring up the profiler, hit record and play the game. Is it running below your target frame time? If it is looking good, it's much better to spend your time working on something else in your game. Prioritize finishing your game over optimization. In this scene, there is high CPU usage. Like I said, occlusion culling reduces GPU usage while increasing CPU usage. If I look into this in the hierarchy, I saw that the shadows are what causing this performance issue. Turns out all the lights were real-time lights. I turned them all into backlights and then the CPU usage lowered. Which is the whole point of optimization, to learn what to do and what not to do. In this case, occlusion culling is not necessary. Therefore, you should learn how to profile first. I have recently released a video to learn profiling for noobs. Check it out if you're interested. Now, once you do realize that you need to optimize some things, and of course you choose occlusion culling, because every tutorial made it look like a 5-minute fix. This thing requires a lot of time to set up, and there will be a lot of playtesting. I have made games with occlusion culling, and I've learned this from my experience and pain. Sometimes there's a light that bleeds through from another room. Sometimes things don't just get occluded for some reason. Stuff like that happens. So let me tell you how to do occlusion culling for real. Step 2, since step 1 is actually profiling, is to mark objects static. But it's not as simple as selecting many objects and then clicking on this checkbox. We need to go to individual object and decide which type of static it is. You can open this by clicking on this drop down next to it. All of these does different things, and there's a reason why this exists. Okay? You should almost never blindly set to static to get things done. That is the easy to do and hope that everything is okay kind of way. You need to mark objects as either Occluder static or Occludee static, or sometimes both. Occluder static are meant for things that block vision, like walls, mountains, buildings, and floors. They hide other objects. Occludee static marks objects that can be hidden, and they are often set on small objects, props, and decor items. In short, Occluder static equals big objects, Occludee static equals small objects. Also, marking small objects as Occluder static, which is the wrong way, will make the CPU spend time calculating if this object blocks vision for other objects, which is a waste of CPU time. Some objects are fine to be set both. For example, a big statue that can both hide and be hidden. It's a fair case. Now, if your scene is an interior environment, then all big objects or occluders should also be marked occludees. This is because of the presence of walls and floors, which should also be marked both. However, this alembic, that's what it's called, is big enough. But in this case, it doesn't make sense to mark it as an occluder, but rather as an occludee, because there is nothing on the other side of the mesh, just a huge wall. This is why going through individual objects is important. This saves memory and CPU usage at the expense of development time. Here's a big tip that will save you a lot of time. Create prefabs for every object in the game, and this way you can mark small objects as occludees, and for the big objects you can mark them both occluder and occludee static, and then go to individual instances in the scene and make changes if necessary. For buildings that are far away and small, it's better to disable the game object or the renderer and then hide them with fog or a cloud. Video games do that very often, and once you start recognizing these little things and why they exist, you start to understand why GTA 6 is taking too long. This process of setting things to occluder and occludee static could take long, maybe an hour or two depending on how big your game is. But it is something that you should definitely do to achieve better results. Step 3 is to go to Window, Rendering, Occlusion Culling. This pops a new window which has 3 main tabs. Object allows you to filter and select which objects are occluders or occludees and create occlusion areas. Bake, these are settings for the baking process. Visualization. Here you can see how culling behaves with your camera. Here, if your game is big and you can afford more CPU usage, you can specify occlusion areas. These are zones where high precision culling matters, like corridors, rooms, or complex interiors. This makes the bake more efficient and accurate in key locations. So if occlusion culling is weird in some areas, try making it more accurate by creating an occlusion area. And the final step is to bake. Go to the Bake tab and tweak the settings for your scene. Smallest occluder means only objects that are bigger than this counts as blockers. They are in meters. It's like setting the minimum size for objects to act as occluders. When should you adjust this? Let's say you're building an interior with a lot of pillars. If you set the smallest occluder to 5 meter, pillars that are 1 meter wide won't act as occluders. They won't hide anything behind them. If you want these pillars to actually block things behind them, then reduce the smallest occluder to less than 1 meters. Smallest hole means gaps smaller than this are ignored. This controls what gaps or holes are considered valid line of sight paths by the culling system. We have holes in this mesh, but let's say we don't want Unity to waste time rendering what's visible through this hole. You can now set smallest hole bigger than the size of that hole, and Unity will treat the mesh as if it's a solid wall occluder, and objects through the gaps won't be visible. Conversely, if you want objects behind them to be visible, make sure that smallest hole is set smaller than the hole. If things are glitchy still, I'd argue it's better to not make this mesh an occluder. And finally, backface threshold controls how much of an object's back is ignored in occlusion tests. This is something you need to test, especially if you are rendering back faces. Sometimes you have them, like when you're inside elevators, where you need to be inside and also show it from the outside. And the final step is to bake. Go to the bake tab, tweak these settings, and yeah, then you hit bake. Once baking is over, you can see these blue cubes. This is how the algorithm works, and you don't want these cubes to be this large. The cubes should divide your scene into small chunks, and the cubes are big because of a high smallest occluder value. Let's set this to a way smaller value and bake again. There we go. This is sort of the ideal size that you'd want. You want the cubes to divide your map into several chunks. Now, making sure that the visualization tab is open and you select your camera and rotate it, even in the scene view, you can see occlusion culling taking an effect. And there is an important step left: playtesting. Explore your entire world, especially with lighting. I've had traumatic experiences from my past due to occlusion culling. They work very weirdly with mixed lights. You need to play around with the settings, bake again, make occlusion areas, and you're good. Also, remember to profile afterwards. This is important, just so that you actually know that things are doing better. This algorithm is not perfect and does have some drawbacks. As promised, let's look at some of them. Unpredictable culling. In certain scenes, especially with complex or modular geometry, occlusion culling may fail to hide objects that you expect, or worse, cull objects visible to the player. No algorithm is ever perfect. Unity takes a good enough, fast enough approach that can lead to both overdraw and underdraw. In this example, after playtesting, I can see that these walls are getting culled for no reason. And in order to solve this, I created an occlusion area and placed around that area where the walls are. And then I rebaked the occlusion data and the glitch was gone. And secondly, runtime resource cost. Large occlusion data equals increased disk space, RAM usage, and may slow loading times. This also means if little of your scene is ever truly hidden, occlusion culling can use more resources than it saves. This thing takes a good bit of time. And it's honestly not that bad, but it's not optimal for certain types of games and situations. So let's take a look at when not to use occlusion culling. Open world games or scenes with few occluders with big or empty outdoor areas gain only a little and may actually suffer from using occlusion culling. When you have a lightweight CPU budget, especially on mobile, occlusion culling is not recommended always, as this can increase CPU load. Also, when objects are visible at all times, there is minimal benefit to occlusion culling, and there is added complexity. So, when is occlusion culling best used? Indoor scenes with multiple rooms or corridors. When you're inside buildings, interiors, dungeons, mazes, rooms separated by walls are a total green light. Scenes with large, opaque, static objects, like city streets with tall buildings, canyons, and alleys. Also, when there is level design with distinct zones, like multi-zone interiors, sci-fi ships, or office buildings. In short, you can safely use occlusion culling when your scene is mostly static, features large occluding geometry, and the player/camera is often enclosed or boxed in by walls, terrain, or buildings. Always remember to profile your scene before and after enabling occlusion culling to ensure you're actually getting actual performance improvements and not just adding overhead. Let me know what you think of this video, and you can yell at me and give suggestions below. Check out the full playlist for hidden Unity tips like these. The link is in the description. I'll see you next time. Take care, and as always, I love you. Bye.